Hi all, so once again welcome to Mathematics Mania YouTube channel. Yeah, in our previous video we used Leibnitz theorem and proved a few of the nth derivative problems. Yeah, so next topic is finding the coefficient of y or differential coefficients. We were just finding like yn of something, and we were proving some of the results, something like this: 1 minus x square equal to yn plus 2, 2n plus something like that. So the next topic is find yn of 0. I mean nth derivative we have found. So when x is equal to 0, we need to find what will be the yn. So that's called finding the coefficient of y. So differential coefficient of y when x equal to 0. So we'll see how to do that. So the first part of the thing will remain as it is, like using the Leibniz theorem. Yeah, so we'll start with whatever is given, and so we'll see y is equal to sine of a sine inverse x. Then prove that 1 minus x square yn plus 2 minus 2n plus 1 into yn plus 1 minus n square minus y square yn will be equal to 0, and find yn of 0 and yn of x at x equal to 0, which means we may have to find the differential coefficient of y at x equal to 0. Okay, so we'll start the solution. Okay, so y is equal to sine of a into sine inverse x. So differentiating y with respect to x, the first order derivative y1 will be sine of something will become cos of a into sine inverse x, right? And we have to take the derivative of the sine inverse x also. Since a is a constant along with sine inverse x, so a should be multiplied, and sine inverse x derivative is 1 divided by root of 1 minus x square. So that will become, this root of 1 minus x square I am multiplying to the other side, so this will become 1 minus x square into y1 will be equal to, a is a constant, so a into cos of a sine inverse x. Okay, now squaring on both the sides. Squaring on both sides, what happens? Root of 1 minus x square into y1 will become 1 minus x square into y1 square will be equal to, this will become a square into cos square of a sine inverse x, right? Cos square of a sine inverse x. So if we carefully observe here, this cos square term, we have sine square x plus cos square x will be equal to 1. So this cos square x can be written as 1 minus sine square x. So that implies 1 minus x square into y1 square will be equal to a square into this, I will write it as 1 minus sine square of a sine inverse x. Why? Because I have sine of a sine inverse x as y, so it will be easy for me to substitute it as y square, and further simplification will be easy. So I just replaced cos square of a sine inverse x by sine square of a sine inverse x. Sine square of a sine inverse x is nothing but sine of a sine inverse x the whole square, right? So what happens? 1 minus x square into y1 square will become a square into 1 minus, see, y is equal to sine of a sine inverse x, so sine square a sine inverse x will become y square, right? Yeah, so differentiating the above equation with respect to x again, what happens here? 1 minus x square into y1 square equal to a square into 1 minus y square is there. Let's apply the product rule here. So first function into 1 minus x square into y1 square will become 2y1 into derivative of y1 will become y2 plus derivative of 1 minus x square is minus 2x into y1 square, which will be equal to, a square is a constant, let's keep it as it is, derivative of 1 is 0 minus derivative of y square is 2y into y1. Okay, so here 2y1 is common in all the terms, so let's take 2y1 common outside, so that will become 1 minus x square into y2 minus 2y1 I have taken common already outside, so what is remaining is only xy1 will be equal to a square into 2y1 let me take common here also. Okay, so what remains inside is only minus y, because 2y1 I have taken common outside, so only y will remain. So here 2y1 I have taken, so this 2y1 and this 2y1 can be cancelled. So 1 minus x square into y2 minus xy1. Okay, let's move this to this side. So plus a square plus so a square minus a square y I will move to this side, so it will become plus a square y will be equal to 0. Okay, now we have got an expression in y1 y2. Now let's apply the Leibnitz rule. So on Leibnitz rule what happens? nc0 1 minus x square into yn plus of 2 plus nc1. So the derivative of 1 minus x square is minus 2x into yn plus of 1 plus nc2 into the derivative of minus 2x is minus 2 into yn. So that ends the nth derivative of the first term, because the next term will become 0. Minus sign is there, take minus. So xy1 we have to do. So nc0 x into yn plus 1 plus nc1 derivative of x is 1, so this will become yn. Okay, so the second term has become already 0, so we can stop it here. Plus a square derivative nth derivative of y is yn will be equal to 0. So nc0 is nothing but 1, so that will be 1 minus x square into yn plus 2 plus nc1 is nothing but n, so this will become minus is already there, so minus 2nx into yn plus 1. Okay, plus nc2 is nothing but n into n minus 1, n minus 2 factorial in the numerator and denominator will get cancelled, divided by 2 factorial into minus 2 into yn. Open this minus sign, so nc0 is 1, so minus x yn plus 1, and this nc1 is n itself, so this will become minus nyn plus a square yn will be equal to 0. Now 1 minus x square into yn plus 2 minus, here minus is there, so I have taken minus inside outside, 2nx into yn plus 1 plus this 2 and this 2 factorial can be cancelled, so n into n minus 1 will be n square minus n. 1 minus is there, so it will become n minus n square into yn. Also we have minus x yn plus 1 term, minus nyn term is there, plus a square yn term whatever is there I will write as it is. So now when we compare here, so xyn plus 1 and xyn plus 1 are common, so let me take it outside. 1 minus x square into yn plus 2 minus 2n plus 1 into x of yn plus 1 plus, observe here, n minus n square. Okay, n minus n square yn, and here minus n is there, here plus nyn and minus nyn is there, so they will get cancel out each other. Okay, so what remains inside is minus n square plus a square will remain inside, that will be into a square minus n square yn will be equal to 0, which is the required thing to be proved. So we will have the second part of the question to be proved, that is now we have got an equation for second order, I mean the n plus 2th derivative of y. Now we have to find yn of 0, that we will see how to find. Thank you for watching, and please let me know if you have any questions and queries, or on which topic you want me to make the video, and please subscribe. Thank you.